I started work on cannabinoids many years ago, there was absolutely no interest. As a matter of fact, when I asked for a grant, a very small grant, I was told nobody uses cannabis, nobody smokes marijuana in the US. When you have something more relevant, please apply. Well, things have changed a bit. As a matter of fact, just last year, Nature, one of the major scientific journals, had 4 reviews on cannabinoids, and here is one of the first, the one that we wrote. On the first page, they had a brain and cannabis coming out of it, and people told us that, yes, this is what's happening. So many people are interested. As written by one of the groups in the US at the NIH, and they wrote down that modulating endocannabinoid activity may have therapeutic potential in almost all diseases affecting humans. Now, this is a very, very strong statement. We haven't heard of anything of this sort with the numerous neurotransmitters that we already know, that the dopamine, the serotonin, and so on. None of them really has a therapeutic potential in all diseases affecting humans. And this being the case, I'm not surprised that there has been so much interest over the last couple of years. Well, as was mentioned before, cannabis has been used for many thousands of years, starting from China, India, and the Middle East. And it was used essentially in the same way that cannabis is used today, as a drug that takes away the mind, getting high, as a drug for apparently neurological diseases, and possibly in many cases, particularly in India, for religious rites. When we speak of cannabis, most people, most users, most investigators will think of the plant alone, the compounds that are found in the plant, the compounds that have been investigated so thoroughly, the plant that will, as we heard before, will come to a business of so many billions of dollars. But from a scientific point of view, from a medical point of view, this is just one of the 3 major domains of cannabis research. These are the plant compounds, the cannabinoid compounds that we produce, that animals produce, and compounds that are produced by plants or by mammalians that are closely related to the endogenous cannabinoids. And these compounds are active in a huge variety of disease states. So I will try within the next half hour to tell you a bit of what's going on in all these 3 fields. Let's start, of course, with the plants. Many years ago, when we started work, we were surprised to find out that contrary to opium, contrary to the cocaine and so on, the chemistry was not well known. So we went ahead isolating the constituents of cannabis. When those of you who have forgotten your chemistry, you can see that on the right-hand side, there is something that is more or less constant. That's the aromatic part of the molecule. But on the left side, one can see a lot of changes. These are terpenoids that are bound to the aromatic part. And these changes have led to something like about 100 compounds that are present in cannabis. Well, these 100 compounds, and we have given them various names, cannabigerol, cannabichromin, cannabicyclol, and so on. But again, not surprisingly, these compounds are actually not made by the plant. The plant makes compounds, the so-called cannabinoid acids, and these acids, which are not stable, are slowly converted into the compound that we know, THC, cannabidiol, and so on. But surprisingly, the cannabinoid acids, which are actually the compounds that the plant makes, have not been investigated thoroughly. And the reason for that is that they are not stable. And scientists don't like to work with non-stable compounds because if given to a mouse or to a human, one doesn't know whether the compound itself is active or whether the compounds that are derived from these acids are stable. So for many decades, very, very little work was done on the acids. Well, in order to work on them, one has to stabilize them, make them stable so they will not convert into all the other compounds and we can investigate them. Well, by a small chemical change, one can do that. One can take the cannabidiolic acid, one can take the tetrahydrocannabinol acids and so on, and convert these acids into stable forms. And indeed, these derivatives, which we call methyl esters, the chemistry is not important, have turned out, when investigated, and you can see that the investigations are pretty new. They were published last year and this year. These cannabis acids are very, very active on their own. Work that was done here in Israel shows that one of them, at least, reduces depression, very powerfully reduces depression in mice so far. Getting into the clinic is a major problem. It needs a lot of money, a lot of organization. I hope that we shall be able to get this particular compound into the clinic and see whether it really lowers depression, as we have seen in animals. But the same is true for anxiety. It lowers anxiety in rats. Again, in collaboration with people, with scientists in England and in Canada, we found that it lowers anxiety in rats. So chances are that within the next few years, we shall see a lot of work on the acids, not necessarily on the THC and CBD, but on the CBD acid and the THC acid, because it turns out that they are even more active than cannabidiol, that is supposed to reach a market of 20 billion, 25 billion, whatever. But the two compounds that have been investigated so far in great detail are cannabidiol and THC. The THC, of course, is a compound that causes the psychoactivity, the compound that causes the activity so well known with hashish and marijuana. And although it is an approved drug today, one can take it for quite a few things. It is not a major drug because of the changes that it causes. Cannabidiol, on the other hand, has become a major compound, major drug, and essentially all growers are trying now to find ways to have strains that contain huge amounts of cannabidiol, because this is the compound that is being widely used. Well, let's say a few words about THC actions. We know that it acts on pain, it eliminates the side effects of cancer chemotherapy. It is well used in post-trauma. We did some experiments on post-trauma, and it was found that indeed THC at low levels lowers post-trauma. It doesn't cure post-trauma, but it certainly has very positive effects on the symptoms of post-trauma. Post-traumatic patients, for example, many of them cannot sleep. They're afraid to go to sleep because they can wake up in the middle of the night with the trauma coming back to them. And the trauma could be something happened in a war, or many other things that can bring trauma. So the patients they're afraid to go to sleep, as I said. But taking THC makes possible for many of these patients to sleep. So post-trauma patients on their own or through their physicians do get cannabis with THC, trying to suppress some of the symptoms of post-trauma. But as I said before, cannabidiol is much more important as a therapeutic agent. And I'll give just a few examples. Epilepsy. Many years ago, about 35 years ago, we did a clinical trial on epilepsy, and this was done in South America, in Sao Paulo. And after doing work on mice and rats, and other groups doing work on mice and rats, we did a clinical trial, and it was given to 15 epileptic patients that nothing else was helping them at that point. And these epileptic patients, some of them got a placebo, namely just the oil, but not no CBD, and the other half got large amounts of cannabidiol. We needed 0.5 kilogram of cannabidiol, which we isolated in the lab, a lot of work. And indeed, when treated for several months, these patients that nothing was helping them anymore were helped. 4 out of the 8 patients that got the cannabidiol had no attacks, or very few attacks. 3 had only partial improvement, only 1 was not helped. So we thought at that time, silly us, that, well, here is something showing that cannabidiol, a major compound, which we knew is not toxic, which doesn't cause side effects, is a good compound in epilepsy. And that was 35 years ago. Nothing happened for about 25 years. So nobody was interested. Then there was public pressure in the US. Parents found that cannabis with a lot of cannabidiol helps. And this pressure made the US government authority to allow a clinical trial, and it was shown indeed in a major clinical trial that cannabidiol helps children with specific epilepsies to be treated and treated well. So now cannabidiol, under the name of Epidiolex, something like that, is approved as a drug, not for everything, but for specific epilepsy in children. So why did we have to wait for 30 years? We could have helped, we meaning people that work with cannabis and physicians, we could have helped thousands of children. Well, this hopefully will be a lesson to advance cannabidiol in many other fields. As we know, cannabidiol is indeed very active in other fields. For example, diabetes type 1, which is an autoimmune disease, a disease that the body attacks itself. And we have found in animals that cannabidiol is an excellent drug in autoimmune diseases, particularly in diabetes. We have seen that animals with type 1 diabetes, if given CBD, only a small amount of the cells that produce insulin are affected. But if they don't get CBD, essentially all the cells that produce insulin are destroyed or are not intact. So why shouldn't we have clinical trials with CBD in diabetes? But there are no clinical trials in diabetes type 1. Why not? We are missing something, but there we are. In one field, there is indeed use of cannabidiol in the clinic at the moment, at least in advanced clinical trials, and this is graft versus host disease. Dr. Yeshurun, the Beilinson Hospital, found that cannabidiol blocks the effects of bone marrow transplant. Now, quite a few patients with cancer have to have bone marrow transplant. It is very effective in many cases, but this is an outside, something that is put into the body from the outside. So the body attacks the new bone marrow, and the new bone marrow attacks the body, and the patient is sick, sometimes very sick. Well, but this is a kind of an autoimmune disease, and therefore Yeshurun thought, rightly so, that maybe cannabidiol will help. Indeed, it helped to a large extent, and now CBD by Dr. Yeshurun and a company that supports him, CBD is in a clinical trial, and I hope that it will be introduced as a new drug in graft versus host disease. Schizophrenia is a disease that infects about 1% of the population. And that's a huge, huge number of patients. We had done some work on animals and a bit in a small human trial, and we showed that large doses of cannabidiol is very effective. So a group in Germany, Leveke and his group in Germany, tried using high doses of cannabidiol in schizophrenia in patients that were getting other drugs, but they were not very helping them much, but they were given, and they compared CBD with a well-known anti-schizophrenia drug. Both drugs acted to the same extent, but the drug that's being used today, amisulpride, causes a lot of side effects, and many of the patients don't want to use it because of the side effects. Cannabidiol at large doses did the same, namely it helped with the attacks. There were very, very few schizophrenic attacks. It caused no side effects, and the patients really approved, very highly approved, the use of cannabidiol in schizophrenia. And that was about 5 years ago. Nothing has happened since. Why cannot we introduce cannabidiol as a drug in schizophrenia? There is very strong evidence that it will help. And we need drugs in schizophrenia. But there we are, 5 years after these clinical trials, CBD is not being used in schizophrenia. On the other hand, THC can cause an attack. So it is not possible, it should not, patients with schizophrenia should not take medical cannabis that may contain some THC. They should use pure CBD or CBD with many of the other compounds that are present in cannabis, but not with THC. But there are no clinical trials in cancer, in inflammations, in brain injury, in many of the autoimmune disease. Why? Here we have a compound that causes no side effect, and there are pretty good preclinical results with CBD. I hope that within the next few years, clinical trials will show that they can be used, at least in some of these diseases. Now, this is the first part of what I wanted to say, where I said there are three areas of cannabinoid research. We knew a lot about the THC, the action of THC, a little bit about the action of CBD. We didn't know the mechanism. Then it turned out that there is a receptor, that the body has proteins that THC binds to them, and it starts the activity of THC. Now, the body doesn't contain receptors because there is a plant out there. It has receptors because we produce compounds that can activate when needed. So we went ahead about 20 years ago, went ahead looking for these compounds. And these compounds are really relevant because the receptors, these specific receptors for cannabinoid, are present in those areas that are very typical for cannabis. The movement control, movement coordination, learning, memory, high cognitive function, and so on. So obviously here we have something very significant, something that is typical for cannabis. And indeed, after quite a lot of work, several years of work by a lot of collaborators, we found that our body makes cannabinoids. Structurally, from a chemical point of view, they're different. THC, you see on the top, is a compound that comes from the plant, but the two compounds on the bottom, one we call an Endomite and the other is known as 2-AG. These two compounds, which are chemically completely different, you can see that they have nothing with the THC itself, but they have the same activity. They bind to the same receptor, they cause the same activities. In one thing they are different. THC stays in the body for a longer period of time, and therefore it causes all the marijuana effects. These compounds, anandamide and 2-AG, which we produce, these compounds are formed when and where needed. They act, let's say in pain. Somebody is in pain, Endomite will be formed around the pain area. It will act on the pain, and then it will be broken down, so we don't see the side effects of THC with these compounds. Well, so today we have something called the endocannabinoid system, which contains these receptors and the two compounds which we found that are like THC, and they are the enzymes that form these compounds, the enzymes that break these compounds. So the endocannabinoid system is of major importance, a major system. And here is a list of some of the effects that are some of the conditions that are affected by endocannabinoid. And you can see it's a lot. Anxiety and appetite and bone formation and so on. And I haven't put on this slide about most of the things that we know about. So I will give just one example. Don't have time for more. Professor Esti Shohami, who I collaborate with her, wanted to know what happens with the endocannabinoid system in brain trauma. She's a specialist in brain trauma, and she looked at animals with brain trauma, and she saw that one of these endogenous cannabinoids, one of the cannabinoids that we make, goes up. This is the red thing that you see in the middle. Levels of 2-AG after brain trauma go up tremendously. Is it because the brain doesn't know what it's doing, it has been traumatized? Or is it a reaction of the brain to the trauma, trying to prevent some of the effects of the trauma? So we synthesized large amounts of 2-AG and gave them to mice that had undergone brain trauma. And indeed, we saw that 2-AG, the endogenous cannabinoid, blocks up to 50% of the damage caused by the brain trauma. So here we have potentially a drug for something that's very important. We don't have drugs that affect brain trauma. Hopefully, it shall be used sometime. Just only one word, the second receptor was found. And this receptor, which does not cause all the effects of CBD, of THC, it doesn't cause the high. On the contrary, when it is acted upon, when a compound binds to the CB2 receptor, it causes a large number of very positive reactions, and it is essentially a parallel system to the immune system. We have an immune system that guards us against a variety of diseases. It turns out that the CB2 cannabinoid receptor, which is affected both by THC and by the compounds we make, by the endogenous cannabinoid, is very effective in heart problems, in atherosclerosis, in stroke, in rheumatoid arthritis, and so on. Here are compounds, don't pay attention to the chemistry, which are specific for the CB2 receptor, and companies are developing compounds of this type, and I assume that we shall have drugs based on the CB2 receptor within a few years, and we still don't know whether it will go for many diseases or for specific ones. And now, the last part of my talk. I spoke of three areas, three domains of cannabinoid activity. One had to do with the plant cannabinoids. One had to do with the cannabinoids we make, Endomite and 2-AG. And the other came up, strangely enough, by looking at what's happening in the body. In brain injury, two things happen. One of them is production of all kinds of molecules, glutamate, cytokines, and so on. And the lack of them or too much of them, depends on what compound, may bring neuronal cell death. But there is something else, and I spoke about this. There is something else. Brain trauma causes vasoconstriction. The blood vessels constrict. Now, this is not helpful to the brain. So the body tries to go against the vasoconstriction. We looked at THC, we looked at Endomite. No, they help a little bit, not too much. So we went ahead looking for a compound that our body produces, or the mouse brain produces, that goes to prevent or to lower the vasoconstriction. And this was the PhD of a student. And after quite a few years of work, he surprisingly found that the body makes an Endomite-like compound, an additional one, which does not bind to the receptors, but it is chemically very close to an Endomite. And this compound strongly potentiates the effect of the body fighting against the vasoconstriction. So here is something that our body makes as a prevention of a disease, if you wish, of vasoconstriction. So we went ahead looking for additional compounds. Now, our body has about 100 compounds of this type. Now, the body doesn't make these compounds because it has nothing else to do. It makes them because of certain reasons. So we present the results of two large investigations that we did over the years. One of them has to do with bones. It is well known that bones and their structure, bones are not something that we make at the age of 5 and we have the same bones until the age of 95. They change all the time. They're broken down and rebuilt, broken down and rebuilt all the time. Now there is an equilibrium there, so it's okay. But in women, for example, the hormonal changes that happen after the age of 55 should cause breaking down of the bones to a large extent, much larger extent than in the normal younger person. And yet it doesn't happen. Most women don't have major osteoporosis. So we started looking for what's the reason. And after quite a lot of work, we found that, yes, the body uses one of these 100 compounds, and it is a compound made from olive oil, oleic acid, and amino acid called serine. And this compound is very closely related chemically to an Endomite, to the endogenous compound that we make, the endogenous cannabinoid. So we have 100 compounds that our body makes. Apparently most of them are for a certain reason there, and they prevent damage to the body. An Endomite-like compounds. Now very few people are aware of this. Chances are that within the next 5-10 years, they will become much more important, probably more important than CBD, probably more important than an Endomite, because they affect a huge number of diseases, and that it's not one compound that does all these things. There are 100 compounds that act on a variety of diseases. Here, for example, continue my bone work, when a person or a mice has osteoporosis, the red is the bone that is damaged and doesn't reconstruct itself easily, so it goes down. If we give this compound large amounts that our body makes, the bone will go up again. It's the green going up again. Now, the drugs that we have for osteoporosis block the degradation of the bone, but they don't cause building up of the bone. Here we have a compound that our body makes that builds up the bone, and it is closely related to the cannabinoids. Well, I want to end up with something that we're doing at the moment, and this is addiction. Today, addiction is considered to be a disease. The body looks at addictions, many addictions, addiction to nicotine, smoking cigarettes, addiction to heroin, using opiates, addiction to many other things. The body sees addiction as a disease. If it is a disease, then the body should try to fight it. I mean, this is something that our body does. If there is a disease, the body fights it. How does the body fight diseases? So, in a collaboration with several groups, we looked at how the body fights addiction. And in cannabis, as in many other fields, but particularly in cannabis and cannabinoid, there should be collaboration between chemists, pharmacologists of several that investigate several aspects, and clinicians. So here on addiction, where we have a small group of collaborators, in addition to my group, a group in Virginia in the US, a group in Canada, doing particularly exciting work, and a group in Italy. So we work together. And after quite a long time, after work by several years, we found that our body, or the body of the mice, we can't, nobody yet has donated his own brain, so we have to work with brains of animals. The body makes a compound which attacks the addiction. It blocks the addiction of nicotine in this case. And this compound, again, to our surprise, we found that it is an anandamide-like compound, namely a fatty acid bound to an amino acid, in this case, oleic acid, found in olive oil, and glycine, a very simple amino acid. So our body makes compounds, anandamide-like compounds, cannabinoid compounds, which attack the formation of the addiction. Now, all work that has been done is unaddicted people. Somebody is addicted, people try to help an addicted person, do research on the addicted person. Nobody has done research on those that are not addicted. Why aren't they addicted? Even they smoke a lot. Or why don't they have heroin addiction, although they take heroin? Most of the heroin addicted people, yes, they're addicted, but some of them are not. So the question is why? Well, in the case of nicotine at least, we know why. Because our body forms a compound, a cannabinoid-like compound, and this compound, on one hand, blocks the formation of the addiction, and on the other hand, blocks the effects, the withdrawal effects of the addiction. Not only the nicotine addiction, but also, at least in mice and rats, also the heroin addiction. Now, this is not a small thing. Nicotine, and particularly opiate addiction, is a major, major reason why people cannot stop using heroin or opiates. About 60,000 people died of heroin addiction, overdose, heroin addiction in the US alone in a single year. If we have a compound that can block the withdrawal effects or lower the withdrawal effects, as we have seen in mice and rats, then chances are that people will be able to get out of their addiction with greater ease. We don't know yet. This is going on at the moment, but I repeat, for nicotine, this particular compound that we make, an endomite, cannabinoid-like compound, this particular compound blocks the formation of nicotine addiction, and it also blocks the withdrawal effects of nicotine and the withdrawal effects of opiates. I sincerely hope that this is what we shall see in humans as well. This is something that I just saw, that the OG, oleal glycine, does helps with the withdrawal and helps with the formation. And I want to summarize. The endogenous cannabinoids, or the so-called endocannabinoids, are involved in a large number of physiological processes. THC actually mimics the actions of those compounds that we make. CBD derivatives, we're not sure always of their mechanism, but CBD derivatives may lead to a wide spectrum of novel drugs. Endocannabinoids themselves, or derivatives of these compounds, may lead to better understanding of biological processes as well as to novel drugs. And again, I mentioned the CB2, which may lead to new compounds. So here we have 3 or 4 areas that may lead to novel compounds. The plant cannabinoids and derivatives of the plant cannabinoids, endogenous cannabinoids like anandamide, or derivatives of these compounds, the CB2 compounds which act on the CB2 receptor alone. And I hope that within the next 5, 10, 15 years, we'll see a huge, huge number of new drugs acting according to these three metabolic processes. And I want to thank my collaborators in Israel, in my lab, or in collaborators in other labs, and in particular, my collaborators abroad. You can see we collaborate, or have collaborated with a huge number of colleagues abroad. We meet at meetings, we visit each other, and at some point, we also publish together. Many thanks.